Your data pipeline ran perfectly yesterday, and today it's broken. Why? There's been no code changes, no alerts went off, but something is wrong. Welcome back to Data Engineering 101. I'm Chris, and today we are going to talk about why testing your data is just as important as building that pipeline itself. If you ignore this step, you are not an engineer, you're a gambler. Bad data leads to bad decisions. It kills trust, triggers compliance nightmares, and the costs are real and palpable. Fixing a bad decision made on bad data costs 10 times more than fixing the data issue upstream itself. Your job isn't just moving data, it is protecting it, ensuring that your company has the right information at the right time to make the right decisions. Let's start with some basic tools that you could use today. Our first tool that you could use, assertions. This is one of my favorites to use. Check your assumptions early in your data sets as you're implementing your ETL process. Here's an example. We're going to assert that our ID field for our customers is never null, which is a pretty good bet, right? Especially if it's in the customer table. So here we're going to assert that in our data frame, the customer ID field is not null, and we're going to look at all of the fields. If any of them are null, it's going to return this message saying that null values were found in our customer ID field. All right, our next function that we're going to look at, describe. Again, this is another very robust kind of exploratory data analysis function that you could use to identify things and sanity check numeric fields. Are there any outliers? Are there any crazy min or max or standard deviation values that just don't look right in your data set? So here's an example of that. We're going to check and see if our max price is over $1 million, right? Then it's going to print this warning saying that the max price values are unusually high. We're also going to look at that standard deviation. If there's no deviation in the price, which is almost always going to be wrong, that there's no deviation, then we're going to print this warning saying there's no variance in price. Be sure that you're checking the source for data issues. So those are the types of checks that you can use to kind of validate that the data looks right. In addition, you could also do some manual sampling. Spot check records manually for some of these anomalies. Manual validation is good, but be sure that you are implementing some automation checks that's validating your data all along the way. All right, while you're watching this section, be sure to comment below. What is the most common resiliency issue that you face in building data pipelines today? If it's not covered here, I will build you a script just for that. Let's walk through some specific property-based rules, commonly known as p-tests, and how to handle them when they fail. Property-based testing takes you to the next level in your career. Instead of just testing for specific values, you test the rules your data must always obey. So some examples of that are order dates should never be in the future. Emails should always contain a valid domain. IDs should always be unique. Critical ID fields should never be null. Now, I want to give a shout out. This particular check was highlighted by Rita, who said it best. A basic one that I always check for is nullability. Are there any nulls where I expect data present? It's one of the simplest yet most effective checks to catch missing or incomplete records early. When a test fails, it's not just a red flag. It should trigger a response. If order dates are in the future, quarantine those records, send an alert to the data team, and optionally CC the sales leader to investigate and fix the data at the source. If IDs are duplicated, quarantine those conflicting rows notify the data team, and optionally tag the business contact that owns the transformation for that review. Let your stakeholders know that reports may be omitting some of those records. If required fields are null, quarantine and notify the data team. Then determine if business action is needed. Now, when we're looking through the script here, you're going to notice that we're going to use some regex functions. So regular expression checks, which is regex, right? Regular expression, checks that the email is including a user, an @ symbol, and a valid domain. So I'm going to walk through this script and kind of show you what's going on here. Here's our Python script. Now, I want to go over a handful of things, and then we're going to get into really the nitty-gritty. One, a couple of best practices. When you're writing, whether you are writing just a Python script like this, or you are in Jupyter Notebook or Databricks, always put all the libraries that you're going to be using up at the top. This is a standard best practice. Whether if you're in Jupyter Notebooks or Databricks, then you're going to put this in its own code block at the top of your notebook. Next, we have our function. So this function in particular is for this going to send our email alerts. So first, let's go over really quickly what some of these libraries are. We have our pandas library for our creation of our data frames and data manipulation. We have NumPy for some number analysis. We have RE, which is our regex library. Again, we're going to be using that to check our email addresses. We have our date-time library. That's going to be so that we can set our date-time to today and check and make sure that those order dates are not, in the future. We have our SMTP library, which is how we're going to access our email, and then our email.message, which is how we're going to create the actual body and content of our email message. All right, jumping into our send alert function that we've created. So send alert, we have a handful of parameters here that can be passed in, and one optional. Two optional. One has a default of test and the other one is none. So we have our to and our message, right? This is just who the email is going to. MSG is just the actual body of the email. We want to pass in our pipeline name because that theoretically would be dynamic. And here I'm setting the default as test, but you could pass in a specific pipeline name. And then we have optionally our, again, these last two are optional. And we have our CC, and we're setting that to none because by default, we may not have any people that we're CCing in our email. Now, this next block, we are looking at creating the variables for what we need in order to access our email that we're going to send these alert emails from. So we have our SMTP server. This is the server where that email address lives. We have our port, again, commonly 587 for TLS for our listener. We have our sender email. We have, which I'm calling alerts at gambledataengineering.com. Good practice to create a specific email address that you want to use specifically for your pipeline alerts. Sender password. Again, do not put passwords, do not put credentials in your code directly. Here, this is a example, and I have this in here because I didn't want to go real deep into the security piece, but best practice, put these types of parameters in a key vault or a secret manager, and then access that key vault or secret manager and retrieve that. If you want to know how to do that and you'd like to see me do a whole video on that, put secret manager key vault down in the comments, and if I get enough interest, I'll do a whole separate video just for that. Okay, so next we have a try except block, and this is just error handling, right? For those of you that want to learn more about Python error handling, go back and check out the Python video that we created for error handling. It's in our Python tutorials library. So we have our try block, which is we are opening this email address, email message object, right? So again, this is function from this email.message library that we're importing. So email message. And what this does is it creates an object. It creates basically a bucket that we're going to put all of our email information into so that it can be used to create our actual email. Okay, we have our subject. Like I said, we're going to pass in the specific pipeline name into our subject line so that it is easily identifiable in our email address. We have our from. This is who the email is going to be from. Again, it's going to be from this alerts email. Next, we are concatenating all of the objects that get passed into that to parameter, because you could pass in a list. You might have multiple email addresses that you're going to send this email to. And it's going to be, we're going to use this join function, which is just our concatenator. And it's going to be separated by a semicolon because these are email addresses. And then next we have our email CC, and we're going to do the same thing. And you'll see that this is in a if block, and that is because it's optional. It may or may not exist. Next, we're going to set our content as our message. Again, this is the body of your email. Okay, after that, we have a with block. So basically the with block is saying we're going to use kind of this top part, and then all those other things below it relate back to that function, that object at the top. So with our SMTP library.smtp, we're going to access our server. We're going to pass in our server and our port in order to open up that that connection. And so first we're going to start by starting that listener. We're going to start that TLS. And next, we are going to log into our email with our email and our password. And then finally, we're going to pass that email object, that email message object that we created, into the send message function. And that's going to send our email. It's as simple as that, not real complex. So next, we're going to print that just a confirmation that the alert email was sent. And then here we have in our exception block, we want to print in the in the response that an alert was sent to, and the list of who it was sent to, any CCs, and then our message. Cool. Now we have a couple more variables here, our pipeline and our default email address, and I do this just because if you are sending the email to the same email address for everybody, then just type it once. Don't type it out 5, 10 different times for each of your validation checks. So you're going to set your pipeline name, and optionally, you could pass your pipeline name in from another notebook or from another, your ADF pipeline or whatever the case might be. We are going to set our default email address, right? So again, chris.gamble@gambledataengineering.com. If you're interested in reaching out to me, be sure you reach out to me via this email. If you want specifically this script, feel free to reach out to me via this email, or and when you do that, I will add you to our newsletter list. We send out a weekly newsletter from Gamble Data, and then also you can alternatively go to the website and join our email list there. Okay, next we have our data frame, where we are using pandas to access the CSV file where our data is coming in from. And again, this is where on our local computer, obviously you'll adapt this to your specific use case wherever that file is. We have our order date. So we're going to access that column named order date from our data frame. We're going to explicitly kind of cast, just like you could cast things in with SQL. We are explicitly setting this field as a date time object. And if there are any errors, we're going to try and coerce that data into that data type. So next, we're going to create another variable. This is where that date time library comes in. We're going to set today as our datetime.now.date. Are there any order dates that are greater than today? And so that's just going to make sure that there are no order dates in the future. And then if not, right, if there are some invalid dates, so if not invalid dates.empty, right, we're going to put those into a Parquet file. And we are, again, this is just our invalid dates, right? These are the dates that are greater than today. We're going to put those into a Parquet file, and we're going to count the number of dates so that we could pass into the email message how many invalid dates we found. Okay, next, we're going to check for duplicates. Okay, here's our duplicate ID check. We're going to, again, our data frame .df.duplicated, we're going to use an ID, and we're going to keep false, right? We're going to say, nope, we don't want to keep those. So if not, again, if we're kind of using that reverse, that double negative type logic here, if not dupes.empty, then it's going to put all of those duplicates into a Parquet file that, these are our quarantine files, right? We're going to dump those IDs, that data frame into a Parquet file. We're going to count again, and we're going to, let our users know, let our data team know how many duplicate IDs were found, so that, and then that the records were quarantined and where it's being quarantined to. Now, I want you to tell me right now, down in the comments, what else could we be doing in this script to not have to repeat ourselves, right? One of the main programming concepts is you don't want to repeat yourself over and over again. If you're having to write it out twice, it should probably be a variable. So let me know down in the comments what you think that we could do to change this script to make it a little bit cleaner. Okay. So this next piece is our email format validation. So this one's a little different because we are using that regex library. And so regex, you'll hear me say regex as regular expressions. We have some characters plus a @ symbol plus some more, and then some more @ symbol and some more characters plus a period and then 3 more characters. And then that's it, right? So this is what we're checking for, this formatted string as a regex object. And so if not invalid emails is empty, then we're going to, again, quarantine those invalid emails, send them into a Parquet file. We're going to count them, and then we're going to send the email and the notification to our data team. Now, we got a couple more. Hang with me. We're almost there. Next, we have our null check. Again, this function here, .isNull, this you're going to use a lot as a data engineer. You're going to be checking are fields null. But in this case, we're using it to create a data frame where any customer IDs may be null. There's some qualifications around what null is. We'll do a whole separate video on that later on. But for easy understanding, null means that is empty. Like it is, there's not a empty string. There is nothing there. It's just not there. So again, null IDs.empty. So if there are any empty IDs, then it's going to quarantine that data in our Parquet file. We're going to count the nulls. We're going to send the email. Now, we have another function here that we're creating, and I only segmented this out like this for demonstration purposes so that you can see it all together. But again, normally we would take this function and we would put it up here right after our other function so that we have all of our functions together. It's more maintainable, that your code is more maintainable that way. It's easier to read that way, and it's just better. But for demonstration purposes, I did want to put it down here so that I could read it all together for you. So here we're creating this isNumeric function, and it's going to pass in a value. We're going to try to cast it as float. If it does get cast as a float, meaning that it's some type of numeric value, then we're going to return true. So this is just a Boolean response, right? True or false. Basically ones and zeros, right? True, yes or no. And then if there is an error, any type of value or type error, then it's going to return false and say no, this is not a number. Now we're going to use that for our invalid data types. That's what D-type stands for. Again, this is common nomenclature for data engineers, for programmers to see D-type pop up. This little symbol right here is called a tilde, and it when you see it in square brackets like this, and within for a data frame, for creating a data frame, then it means basically is not. So if the price is not numeric, so if this function, if this returns a false, then it is going to create, again, our quarantined table or parquet in this case, and we're going to send it to our parquet file. And you see here, again, like I mentioned a couple minutes ago, there was a better way, and I want to see who put it in the notes. I'm going to check who came up with that you could explicitly define the quarantine path so that you could use it in your alert message and in when you're creating your file, so that you only have to put it in there once. Again, best practice, if you're typing it twice, it needs to be a variable instead of hard-coded. Again, then you have less points to touch if things change. We have invalid indices, and so we're creating a set called invalid indexes, basically indices. And so we have for every invalid data frame in all of these data frames that we have created here. If not, df_invalid.empty. So basically, if it's not empty, then it is going to add those records into this larger data frame. So next, we are going to create the opposite. We're going to create a valid data frame. And so we're going to drop everything that was invalid. We're going to print how many valid records are remaining. And then we are going to send all of our valid records to our parquet file. So we've quarantined all the bad data. We have we've created a valid data set with all of our good data, because the next step that is a separate, just for ease of explanation, is a separate Python file. We're importing a couple more libraries, and what this is going to do is we're going to push that valid data into our staging table in our database for the rest of our pipeline to handle. And so that's basically what this is doing here. We use SQL Alchemy for our connection to our database. We're using pandas again for our data frame object. We are creating a connection string. Again, you would put all of these parameters, you would retrieve them from your secret manager, your key vault. Again, if you want me to do a whole video on how to do that, let me know down in the comments. Just key vault, secret manager, whatever the case may be, and I'll do a separate video. And then we are creating our connection string to our database. Here, obviously, I'm using SQL Server, but it could be Postgres, it could be your connection to your Snowflake server, whatever the case may be. You'll just have to change some of the string here. We're passing in our username, our password, our server, and our database to create that connection string. Alternatively, you could create your whole connection string as a actual separate secret in your secret manager key vault to pass in explicitly. And then we are, again, setting up that connection to opening that connection to our database. We are reading our parquet file with our valid data, and then we are sending it to our SQL Server with our table name. Our connection is our, again, we've opened up that connection to our SQL Server. If it exists, then we're going to replace that table because this is staging. So we're just kind of swapping out the table. We're going to replace it. And then we don't want any indexes, right? We don't want to pass in a bunch of indexes that don't really mean anything. And then finally, we're just printing out a confirmation message, letting the user know that we have successfully loaded and how many records into our table. These types of logging things are important because if you take all these and say you're putting them into a Docker container, putting them into ADF, maybe running them in a Elastic container, then you want these messages printed out in your logs so that you could see these things, so that it's easier to troubleshoot. So printing these things, don't overdo it, right? But printing these kind of key touch points will help you in your validation, will help you in your troubleshooting when things do pop up. All right. That was our Python script. I know it was really long. I appreciate you hanging with me. And again, if you want a copy of these Python scripts, let me know. Shoot me an email, join our email newsletter list, and I'll get this Python script to you. Again, thank you for hanging with me. I know it was 20 minutes of just a bunch of boring Python script. I hope you enjoyed it. I hope you learned something. Building great pipelines is one thing. Keeping them running consistently and on time is a whole nother. In the next lesson, we're going to be talking about orchestration. And I'm going to show you how to schedule, trigger, and automate your pipelines so that they're not just reliable, they're resilient from end to end. I hope you enjoyed this video. I hope you learned something today and that you have something to take with you to practically use in your real life. And be sure to like and subscribe and hit that bell notification for all of our upcoming lessons and videos. And I will see you next time.